Problem 21. A two-sided coin is unfairly weighted so that when it is tossed, the probability that heads will result is twice the probability that tails will result. If the coin is to be tossed 3 separate times, what is the probability that tails will result on exactly 2 of the tosses? Alright, so let's first talk about if the probability of heads is twice the probability of tails, then one thing you have to know is that together the all the possibilities, the probabilities of all the possibilities have to add up to 1. And so you're going to have to find something like, we would say the probability of heads is 2 times the probability of tails, and the probability of heads plus the probability of tails has to equal 1. So 2 times the, again, if the probability of heads is 2 times the probability of tails, then 2 times the probability of tails plus the probability of tails equals 1, which means then 3 times the probability of tails is 1, and the probability of tails is 1/3. And then that would make sense. Since heads is 2 times that, then heads would be 2/3, and 2/3 plus 1/3 together give you 1 whole. Alright, so the probability of heads is 2/3, and the probability of tails is 1/3. So those are the probabilities of each of those events there. Now the coin is going to be tossed 3 separate times. What is the probability that tails will result on exactly 2 of the tosses? So what you have to do here is you have to list all the possibilities. And when you toss the coin 3 times, you could get all heads. You could get heads, heads, tails. Then you could get heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. There are 8 different possibilities. Again, how you could get that is you have 2 possibilities for each of the tosses. So you have 2 times 2 times 2, which is 8. So you have 8 possible outcomes from this. Now, we want to find how many of those have exactly that will result have tails on exactly 2 of the tosses. And we can see that there are 3 of the cases, 3 of the possible outcomes of flipping the coin 3 times would have tails on exactly 2 of the cases there. And in each of those cases you have a heads times a tails, and the heads is 2/3 and the 2 tails are 1/3 each. And you can see that even though there are 3 different arrangements of those numbers, multiplication is commutative, and each of those come out to be exactly the same value. They all come out to be 2/27. And since each of those are mutually exclusive, you can't be heads, tails, tails, and also tails, heads, tails, or tails, tails, heads. So when they're mutually exclusive, and there's no overlap between them, you can't have 2 of them occur at the same time, then the probability of those 3 is just the sum of those 3. So it comes out to be 2/27 plus 2/27 plus 2/27, or 3 times 2/27, which is 2/9. And the answer would be A in this case. So a number of things that have to happen here. You have to find the probability of that event heads, the probability of the event tails, and then you have to list all of the possible outcomes for this 3 trial set. And 3 of those outcomes would have exactly 2 tails in them. You have to find the probability of each one, and they will each have individually the same probability, 2/27, but because it could happen 3 times, we would add those together and get 2/9. And you should see that if you found the probability of each of those 8 cases and you added them all together, you would get 1, which is the total possibility of outcomes has to have a probability of 1. There are no other options, and so you have accounted for everything there. So the answer here is 2/9.